Hello everybody, my name is Andrei Cotaie, and together with my awesome colleague Cristian Miron, we're going to have a short discussion about incident response in the cloud and RPA. Is this working?
I don't know.
Oh yeah, it's working now. Awesome! Okay, so we have a lot of ground to cover, so let's get started. A couple of words about us. My name is Andrei Cotaie. I am the technical lead of the UiPath security operation team. I have been doing incident response for a while now, for several years, but what I mostly enjoy doing in my free time at work, it's actually research projects, security research projects or automation projects like this one. I am a big fan of Python and automation, and I guess that's the reason why I'm here today at UiPath, where automation gets reinvented. Cool. Christy, take it away.
Hi there. My name is Cristian Miron. I am a security engineer at UiPath. I've been working in IT for the past 12 years, out of which the past 9 have been in security. I was fortunate enough to have early on in my career a mentor that was focused on automation, and I could see the benefits of automation in your day-to-day activities in our industry. And because of that, I gained interest in the field, and I started automating things one step at a time. And that's how I got hired at the company focused on automation now. Enough about us. I know you don't really care who we are. We're here to talk about automating incident response. And before we dive into automating incident response, let's see what it is actually. And when Andrei came up to me asking me to build this slide, I was looking, okay, so what is incident response? And I came up with an awesome answer. That is, incident response is the process you use to respond to incidents, right? And then I realized it makes me sound a bit dumb saying this. So I went to the AI overlords and I asked them to help me out. And they came up with this wonderful definition right here, that it is the step-by-step approach to manage incidents with the ultimate goal of reducing downtime, I forgot already, and improving overall cybersecurity posture. And I like this definition because it says two things that I agree with. First of all, it's step-by-step process, which means it's a perfect candidate for automation. And the second thing is that it has the ultimate goal of improving your cybersecurity posture. And we will see why we're going to focus a lot of effort on automating the incident management side of things, just exactly for this purpose, to improve our cybersecurity posture overall. Cool. Now that we've talked about what we want to automate, let's see exactly how we define our incident response process. What are the steps that I mentioned earlier?
Okay, so if you're like me, when you actually have an incident, every nerve in your body is going to tell you that you have to be hands-on, you have to investigate, you have to understand what's happening there, coordinate, and all the technical, nice, juicy aspects of an incident. But when my manager comes online, the first thing he's going to ask me, hey, where's the Confluence page? Where are we tracking this? It's painful, but he's perfectly right. And that's because if it's not written, it never happened. If it never happened, you never learn. If you never learn, you don't get budget. Now, the idea was for us, in order to actually help the analyst to focus on the first moments of an escalation on the incident, on the technical coordination, to automate some of the incident management side of the house, like creating pages, tickets, spaces, and so on, or coordination channels, so he can actually investigate and have a better understanding of what he has to do there. When we did this, then we realized we actually can automate things like artifact collection and do it really fast with no human intervention. And why not even prepare a forensic environment for that incident, a dedicated forensic environment on the fly. And that's what we're actually going to POC today, all those 3 things that we mentioned before.
Okay, so now that we've talked about the what, let's talk about the how. And how it will be via RPA, in case you didn't see that from the title. Okay, so for those of you unfamiliar with the concept, RPA stands for Robotic Process Automation. In the most plain definition possible, we're talking about software robots that do things on your machine. That's the most broadest definition I can come up with. Cool. We thought it would make sense to do a bit of deep dive into 2 philosophies that you can use when building RPA before moving further. And that is between attended and unattended flows. When we're talking about attended flows, we're talking about systems that run locally on the system. They are triggered by the user. They use the local credentials of that user. And it allows for interaction between the user and the machine. And because of this, it needs a person at the computer. When we're talking about unattended flows, we're talking about flows that are running on a separate VM, on a dedicated VM. They use credentials specific to that VM. And it can notify the person watching the process of updates as it runs. And it started with a schedule trigger or with a queuing mechanism. Cool. Now let's go back and see how we're going to apply this philosophy to automating the incident management side of things.
Okay, so this is my pain. This is what I hate doing when I have incidents, right? So there are two ways we actually can receive an incident. You can receive an incident from an alert coming from your SIEM, or you have an external alert that you actually have to take into consideration. What we're doing on this side of the house, even external notification, we take them and we put them in our SIEM. Why is that? Because once it's there, it's actually going to have a title, a description, a timestamp, a unique ID, and then I can go forward with the automation process. I can follow the same path further. So for us, we basically construct a Confluence page, a wiki page, right? And that's going to be the main phase of the incident. That's where the incident is going to live. This is what we share with upper management. This is where we have post-action items and post-mortem and things like that, right? We're going to create a ticket, an epic, so we're going to have an epic for this incident where we're going to track all related tasks for all teams regarding this incident. A SharePoint page, we're actually going to store evidence, not necessarily evidence, but files like a collaboration space dedicated for this incident with all the teams. And of course, a channel where we're actually going to coordinate. And that's going to be the main place where we're going to coordinate the incident, get everybody there, have all the links, and that's actually where the incident is going to run. Okay, so let's actually see how this looks. So we're going to start with the attentive part of the house. So we are automating the escalation of incidents. So me as an incident handler, when I actually want to automate an incident, I have to start it somehow. And there are two ways you can start it. From an external notification, and you need things like title, description, severity, and so on, right? And you have a small RPA that did something there, we have no idea what. Or from a SIEM incident, right? And from SIEM, I'm just going to basically put the link of my alert there, and automatically the robot is going to take all the information needed and is going to do some of the incident management side of the house. That information actually gets in a queue, so it doesn't disappear, it gets in a queue, it has some items, and all those items are going to have all the information actually submitted to through those two executions of the robot. And then an unattended robot is going to take that information automatically, somehow, magically, and it's going to do all the beautiful incident management side of the house. Now, for today, we're actually not going to highlight the unattended robot, because if we do that, we're not going to say anything and pop magically things are going to appear. But we're going to do an escalation with the attended robot, and then we're going to run the big incident management side of the house robot from the developer tool we have, Studio, and we're going to get there. So this was the escalation. I have the data there. Christy commented, so you're going to see only whites there. Thank you, Christy. Great work. So we're going to use the Studio to run this, and we're going to see some elements of the executions here, right? So initially it's going to start, and actually it's going to get that information from the queue. Then it's going to get all the beautiful credentials it has, and it's going to start the automation in the background. So automation, it can be actually files that I write some functions that can actually have like code for Studio, or even Python scripts that I upload there. So things are already happening in the background. I have things created, Jira tickets, Slack channel. So this ended in several seconds. I have a pop-up with some information there. And let's see actually the incident management side of the house created, right? So I'm actually going to have the Slack channel where, as I told you, this is actually going to run, to exist. And here I have created, we told people add it. I have a topic and a description. So topics are really important, right? Because you basically, people that are going to be added or incident, they have to play by those particular rules and books, right? And we also have here like all the bookmarks for all the things that have been created, like the Confluence page, the SharePoint page, the Jira ticket, and the incident link that from where we started. So everything in just a couple of seconds. If you're actually going to look there, it took around 30 seconds for all of this to execute. And this is the ugly part, the incident management side of the house. We have better things in the future.
Okay, so before we close out the incident management side of things, we're going to highlight three things that we really liked when developing this flow. And the first one is the vault here that you can see, which you can use to store either credentials or strings that you need to call out during your workflow execution. And I like the fact that I can store centrally and in a secure manner credentials, because people tend to do that directly in the script in clear text, and then we have incidents. Okay. And strings you can keep here so that you can call them out during your workflow execution, wherever you may need to do that. The second thing that we're going to show is this bare-bone template of an incident tracking page. And you will see here it has a couple of strings which are not filled out. During the execution of the workflow, we're going to basically do a copy of this page and then start with the find and replace of different strings with the data that we're getting from that centralized vault that I mentioned earlier. And the last thing that we wanted to highlight here was the timeline part that's available here. You will see that for each action that the RPA has taken, it will update this timeline page, this timeline section with the timestamp for each of them. And if you're looking at it, the whole incident management side of things took less than 1 minute to happen, together with all the juicy parts that Andrei mentioned, the SharePoint side, the conference page, the Jira, in less than 1 minute. Cool. Now that we've done with this part, let's go ahead and see how we're going to do cloud forensics. And as an industry, I feel like we've been doing this for a while now, and I think this is one of the best methodologies out there. So we're going to start by doing first a snapshot to capture the non-volatile data of the affected system. And then we're going to go ahead and do a memory dump to cache the volatile data. The moment that we're executing this command, theoretically, we've already started interacting with the system, therefore we're theoretically tampering with the data. And you're going to think, then why are you taking the second snapshot? What's the purpose of it? Well, the purpose of it is to get the memory dump. I could go ahead and ask an SRE or the host owner, hey, can you grant me access to the system? Or can you archive the data from there and upload it here or send it here so that I can grab it and unarchive it and whatever. This takes a lot of time. There are a lot of steps where errors happen. And there's a lot of wait time because somebody is not answering, because somebody doesn't know how to run this command, because somebody doesn't have the privileges for it, and so on. Or I could do a second snapshot of that system, which I will not use for any investigation, because like I said, I've tampered with the system already, it's not usable, but I have the memory dump there. And I can grab it, and I can start doing the analysis straight from that snapshot. Cool. So let's go on ahead now and see how this process will go step by step.
So I try to take everything that Cristian just said there in that beautiful slide with a poster and put it here. So this is actually how the automation looks. First of all, we mostly live in Azure, but this can be applied like in most of the clouds there. So we identify all the compromised or suspect for virtual machines. We identify all the attached disks and we do a snapshot. We automatically copy the snapshot to our forensic RG. From there, we do the memory dump. There are a couple of ways to do the memory dump in cloud. One of them, in Azure, you can have the run command, and you basically can run a command on a VM without actually being the owner of the OS. You can be the owner of the resource or contributor of the resource. Other options are actually to use your EDR. If you can identify the virtual machine, your EDR, most EDR actually have capabilities to do memory dumps, or if not, at least to give you kind of a shell to run the commands to do the dump. Once we have the dumps, we're going to repeat first step. Why is that? Because we want to get that memory dump to us with no human intervention. So if we did a snapshot once and shared them, how hard can it be to do it the second time? And that's basically the entire artifacts collection process. Let's see how this looks from an RPA perspective.
Okay, so we're going to start executing the workflow now, and we're going to skip over the incident management side of things because we've already talked about it and you don't care anymore. Cool. So we're going to start off with an incident link. And we should see now, yeah, the incident management side of things is done. And we're going to start doing the first snapshot here. You should see here on the left that it start taking the snapshot, starting at series 0. It will list all the disks, and it will start taking the first snapshot. Now, we're going to wait a second because it will load the script, and it will identify the OS and run the appropriate command for the memory dump. And then we're going to go ahead and see how the timeline has been updated with these details, showing that the first snapshot has already been taken for this incident. And if you look at the timestamps, you will see that it took less than 2 minutes to take the first snapshot. Actually, it's about 1 minute, if I'm not mistaken. And now we're going to go back to the workflow execution, and we're going to see an output suggesting that the memory dump has finished. And it will start soon to take the second snapshot, right about now. And once it will do that, we will see that the timeline has been updated accordingly with this action as well. Now we're going to go back to our workflow execution, and it will see that it took about 3 minutes to execute, and we're talking about 3 minutes in which we took a snapshot, a memory dump, and another snapshot so that it's easy for us to get the memory dump all in 3 minutes and 15 seconds, if I'm not mistaken. Okay, I don't know how much this incident response process takes in your environments, but I have a feeling it takes longer than 3 minutes. Okay, so now that we got the data, we need actually to analyze it. And in order to analyze it, we need to have a forensic environment set up for it. And how do we do this? We have a Sift workstation template that we create a server from it. We add the SSH keys to that system once we create it. We could have baked this into the image, but we're both not very smart, so we need to do that after. And then we're going to start iterating through each of the snapshots that we've mentioned, and we're going to start attaching the disks to the VM, and we're going to mount the disks to the operating system in order to have access to them and start the analysis.
Okay, cool. So we have everything you saw so far can actually run unattended, like magically happening behind the scenes, and even this part as well. So what we've done for the next part, we actually took those robots and make them independent, especially to understand what's happening there. So from what Cristi showed before, we have 2 snapshots that have been created and delivered to me. Like the next step I want is actually to create a forensic VM. And we already have an image of a Sift workstation there, so we're just going to input some parameters like the name of the incident, the unique name of the incident, and the region, and basically that is going to be it. Some API calls, and we're magically going to have there a forensic machine created specifically for this incident, right? So really, really fast. That's what actually we love about the RPA side of the house. Okay, so going further, we have snapshots. Snapshots are awesome, but I cannot attach them and I cannot analyze them. So what I need to convert my snapshots. So again, we have a robot. When we're doing the unattended part, like all those parameters are automatically passed from one workflow to another, so it actually doesn't require any kind of human intervention. To create a disk from snapshots, again, it's a basic API command from Microsoft, request actually. You just need some input parameters like what is the snapshot you want to convert and where is the region you actually need to create it. And basically that was it. It executed fast and we have the snapshots ready to be attached. And if I refresh, you're going to see that those snapshots actually have been added there. Cool. So the next part is actually attaching the disk to the virtual machine, right? So I can start actually doing forensic on them. Similar again, what I need actually the unique ID of the virtual machine. To know what I attach, I need the unique ID of the disk that I'm attaching, and I need the disk number, the LAN number. Basically, when we're doing the unattended part, this is a for loop, so it automatically increments the LAN number, and we take care not to override the disk already attached. Here we actually have to manually insert it. So again, same pattern for the second snapshot, the one that actually has the memory dump, the virtual machine disk, the disk number, then the disk ID, and basically that was it. RPA is going to execute magically in the background, and I'm going to have both of the disks attached there. So, as I told you, things are going really fast. Cool. So we get to the last part of this forensic lab readiness, and I need to mount my volumes, right? I managed to attach the disk, which is great. They're there, but I cannot still read them because I need to mount them. So we found this Python script online. We changed it a little, and it does really awesome. It basically identifies volumes that exist there but haven't been mounted, and well, executes the commands, and that's it. Now I have a critical error in my logic here. I'm not sure if anybody can see it. I have a mount command there, and that mount command is missing something vital, something that otherwise this is not going to stand. I'm missing the read-only flag and the loop flag. So, Cristi, we have to go back and redo our steps there. Cool. Now, the problem is we don't have a good robot activity to do SCP. So for this, we're going to make our robot actually run PowerShell ISS. So once I input the parameters needed for this, my robot is going to open PowerShell ISS. Yeah, that's a robot doing that. That's not me. It's going to do an SCP command. Wait. You're not seeing. The slide is blocked. Incident response team is coming right now. Hold a second. Okay. It's still not. I mean, I can see it down there, but it's a pause. Man, so you're close, so close to the final. Cool, we go again. I have this beautiful script that I actually need to get there, and I'm going to do a robot for that. And my robot needs to do SCP. I don't have a native activity for SCP, so my robot is actually going around PowerShell ICE. And what you're seeing there is actually a robot, a beautiful robot that's executing that command and moving that file there. And after that, I'm going to do some SSH on the forensic box to check that everything is all right. So I'm going to do a basic QMI, and that's me there. And the next thing I'm going to do an LS to make sure, like, did my file SCP correctly there? And yeah, the last file there, mountain.dap, is present. So next, I'm just going to execute the file. I told it it's going to identify the mounts, it's going to, the volumes, it's going to mount them. So those are all the output and all the commands that are going to be executed. So the last step I'm going to do here, I'm going to do just an LS in the path where I mounted my volumes that have been attached. And well, here they are. So that actually went pretty fast, even for individual separated RPA robots instead of one attended one.
Okay, and the last thing we're going to show right now is the fact that we actually have the data. I don't know about you, but I don't trust Andrei. He seems quite shady for me. Okay, so we're going to go now and see basically at the mount point to see the data, and I think should be about now, but actually Andrei forgot to sudo.
We need to sudo.
And we're going to go again now, and we're going to NLS. And here you go. Here's the file with the memory dump. So we're ready to start our investigation, basically. And now that we can start our investigation, this is where we're going to end our slides. Okay, so basically this is what we wanted to cover. We have next steps prepared, or next steps that we're taking into consideration. That is that we want to first start tackling AWS environments as well. We will need to make some changes here. We will need to potentially leverage our EDR service to do this. One other thing on our roadmap is to start making our templates flexible and available to our customers so that they can be adapted to each environment customization and used accordingly. And the last thing is we'll need to keep up with the changes in OS, in cloud infrastructure, in tooling and attacker techniques so that the flow remains relevant in the future. And that's about it for that. Let's close out with the conclusions. The conclusions are that incident management is a necessary evil. I mentioned this in the first slide, that we need to document things, and that's why we're doing this via RPA, because we hate it, but we need to, because if we don't learn from our mistakes, we will keep on repeating them, and we will find ourselves in the same incident over and over again. And the second thing is that we are striving to work smarter and not harder. We're trying to remove the tedious tasks from our day-to-day activities so that we can focus on research projects like this one. And last but not least, we're trying to make everything as repeatable and as clearly defined processes in order to be perfect candidates for automation. And I believe that is all from our side, unless, Andrei, you think I've missed something?
No, just a couple of comments. So RPA is not a security tool, but RPA actually can be whatever you need it to be. We're using it for incident response. We have other projects with insider threats. We're using it for things like here where automation is time sensitive, and we're actually using it a lot for quick and dirty projects where we need to automate something really fast and not think about it too much. I guess my main conclusion is that technology evolves, and we need to evolve with it and embrace it, not oppose it. Thank you.
Thank you.
How do you deal with encrypted files and passwords while doing forensic analysis?
Passwords, you mean for what? For
I mean, encrypted files or sensitive data that is encrypted, and while you do it.
I presume you mean encrypted volumes?
Encrypted volumes, sorry.
Sure. Well, I know how to do that in Azure. In AWS, I actually haven't done this in Azure, so it's on our list to do.
Okay, thank you.
Hey guys, nice presentation. I have a question. Why RPA and not just Python scripting from the start? Why is RPA faster from your point of view?
Well, there are a couple of things, not necessarily faster, it's more reliable. And one of the things me and Christy love, we have the credential in the vault somewhere. We don't have to store them on disk. We do the unintended part, especially because we might have important service principals with a lot of permissions, and I don't want those service principals to actually to touch my machine in any way. So by doing the credential in vault and unattended on a machine that I know and I control, I can make sure from where those credentials are accessed, right? So I can control the environment. Then we have centralized logging in the orchestrator part where we can actually see everything that happened. Then again, it's about control. One of the things I like, so in this RPA, I'm actually using Python. Christy might be a PowerShell developer, and we might have somebody else in the team who's doing whatever scripting they're doing, right? We can use the RPA to actually put any kind of technology in one place and execute it as a single flow. Thank you.
Thank you, and thank you for the presentation as well. Actually, I'll take the chance to make it as a two-question set of the things. First of all, I was thinking about maybe the more human part of the incident management process, although this could differ side to side to any company. I was thinking, would this RPA solution be able to also cover, let's say, if you have to show results or to like present some of the findings to the upper manager or to the involved personnel about this, in a way that you could also automatize or partially automatize this thing? And the second one would be about maybe, as a curiosity thing, if there is any error of margin, margin of error related to the tool itself.
Yep, actually awesome questions, all of them, both of them. First of all, there is no incident response without a human. Human are critical. I forgot to mention that on that slide. There are a lot of things that we can automate, but you cannot automate really the human call and the human decision there. Now, automating things for upper management, like what we're doing here, what we're actually planning to do in the next phase, we actually start automatically the forensic analysis side on the forensic machine. If we automate some of the processes, we can automatically take some of the results and put them somewhere. If this entire incident response process actually is used like a framework and things are stored properly like they follow a path, then yeah, we can automate. If you're messy as a human, automation can do as much as you can, but if you don't put all your eggs in the same basket, I know it's bad, but if you put everything in one place, you know how to store, you have a really well-defined human procedure, so anywhere you have a human-defined procedure, you can put RPA on top, right? So you can have the incident response, whatever you have there, all the human input, and then RPA can come at the end and take everything from one place and put them automatically in a place. And we actually do try use RPA to do all kind of metrics internally. As for the second question, I forgot the question. Oh, margin of error. Yeah, so what we're trying to do this as modular as possible. Why? Because some things fail. I can have a shutdown power in my, I don't know, cloud infrastructure. So we're trying to do this as modular and do the critical parts first. So my critical parts are incident management because I want to free my analyst, and that's going to take 30 seconds. And the next part is going to be the artifacts collection, right? So if I fail after the artifact collection, I won't suffer. It's going to take more to put the infrastructure up and running, but I won't suffer. While the artifacts collection, it's important, right? So it depends where it fails. You can have a service principal that's going to expire and you have no idea. Things like that happen.
Congratulations for the presentation. I have a question regarding the keys in the platform. Can the customer manage their own keys, or it's on your possession and you manage their keys? And also,
so the thing is,
sorry, I want to. And also, which are the risks when you have the robots in the lab environment? If can be a lateral movement and can be the robots infected, and which are the risks also? Sorry.
So I can give me a second. I can answer the second one first. There are two types of executions, right? Attended and unattended, right? Attended means you run it on your machine, and unattended you run it on a other machine. It depends how you protect the other machine, right? Yeah, I mean, that's definitely an IT administrator, cloud security, whatever kind of of approach. Now for the client side, what we're trying to do, like that's what UiPath is doing a lot of automations. We're doing internally. They're good, we're proud of, and we're trying to actually to also deliver them to the clients if they want. Nobody is forced to use anything, right? So we have this is good, this works. You can try it out. What we're trying to do, we're trying to do it more like a framework. So anybody who's using this actually has the ability to change it as they want, right? Because I do not know two companies that are doing incident response the same way. Everybody has their own kind of recipe there.